So we know that this is a type of problem, and basically what you're doing in a mixture problem is you're combining two liquids or two things that have already been combined. So it's not like, oh, well, this is pure water, and this is just, let's see, bleach. This is just bleach, so I'm going to mix them together. No, it's going to be like, this container already has, like, this percent of water and this percent of bleach, and this container already has this percent of water and this percent of bleach. What will the percent of the two be when I add them together? That's a mixture problem, okay? So they already have that. Like, you can say, okay, this container, and this is what I get called on to do a lot for guys, like grown men. I have some Roundup in this jug, and I want to add some more Roundup to this jug, but I don't want to completely fry my yard. So how much do I need to add that's already in here so I don't get it too strong, so I don't just torch the entire yard, okay? So that's usually what I have to figure out for people, okay? So Manuel here is taking a college chemistry course, and some of his time is spent in the lab. So he needs a 2% salt solution. However, all he can find in the lab is 120 milliliters of a 10% salt solution. How many milliliters of salt and how many milliliters of water are in a 120 milliliter, or in 120 milliliters of a 10% salt solution? Okay, so how much do we have altogether? 120 milliliters, and how much of that is salt? 10%, right? So what's 10% of 120? What? 12 milliliters, right? Okay, so if it's 120 milliliters and 10% of it is salt, 10% of 120 is 12. So 12 milliliters would be salt. Really quickly, before we start talking percent and this and that. Alright, so 10%, you see the percent sign, that's a show pony, okay? Percents are show ponies. They cannot work. Decimals, that's your workhorse, okay? So if you want to look pretty, you use a percent sign. When you want to do some work, you change it to a decimal, right? Yes? Okay. So if 10% of it is salt, what percent of it is the actual water? 90%. And what's 90% of 120? What? 108. So 108 milliliters of water. Okay? Everyone see where we got those numbers right there? What would the concentration of the salt solution be if Manuel added 80 milliliters of water? Basically, you would have, if he added 80 milliliters of water. How much salt does he have right now? How many milliliters of salt? 12. Okay, and that's out of how much? 120. And he's just going to dump in 80 milliliters of salt. So now he's going to have 12 out of what? 200. So what would that concentration be? What's 12 out of 200 as a percent? 6%. So if he added 80 milliliters of water, he would be at 6%. And then we got another question if he added 180. So let's say he had 12 and he added 180. Alright, you figure that one out. You do that one. So this becomes 12 over what? 12 over 300, which is what percent? 4%. Okay, but what did Manuel actually need? What percent? 2%. Okay, he really needed a 2%. So we're getting closer, right? Come on now. we're going to write and solve an equation to calculate the amount of water Manuel needs to add to the 120 milliliters of 10% salt solution to make a 2% salt solution. We're going to let X represent the amount of water that he needs. Okay, so he has 12, right, out of 120. Do we know how much to add? No, so that's where we're going to put our X. Do we know what it needs to equal? What does it need to equal? 2%, which looks like what? No, it does not look like 0.2. 0.02. 0.2 is what? 20%. 0.02. Okay. That's what we're dealing with. Alright, can you solve that? I hope you can. You can. Okay, so what do I do first to solve it? Put this over 1, and now do you know what to do? Yeah! Good. Go ahead, cross off. I'm going to have 0.02 times 120 plus x equals 12. What's 0.02 times 120? 0.4 plus 0 or 0.02x equals 12. And then what do I do? Subtract 2.4. What's that, like 9.6? And then what? Divide by 0.02. And what is x? What? Well, I got 480 and I got 360. You have to do what? No, this is what you add to it. This is just what you're adding to it. You have to add 480. Yeah. See, we already have the 120. Plus what? Well, plus 480. Yeah. Yeah, it's 480 milliliters. Yes. Alright. Okay. So we have this. I'm going to erase it and go to the next page. Okay. Did it. First time. Alright, let's talk about Keisha. Yeah. Keisha is working on a chemistry experiment, and she has 20 milliliters of a 20% sulfuric acid solution that she's mixing with a 5% sulfuric acid solution. Describe the range of possible combinations for the new solution. So when she mixes them together, what will the percent of sulfuric acid be after she mixes them? When I put this 5 solution in with that 20 solution, is it gonna make it stronger or is it gonna weaken it? It's gonna make it stronger? Right, let me ask you this. Okay, so let's say think of a soda that has ice in it, okay? And you fix you a soda with some ice, and you set it down, and you walk away from it. What happens to that soda and the ice? Right, it waters it down, right? So the soda isn't as strong as it once was. So you come back in, you're like, so you make a new one. New soda, new ice. Which one's stronger tasting soda? The new one, right? Well, then Mom comes in and she's like, you're not wasting that soda. And she makes you pour them into the same cup. What happens? Yeah, it weakens even the stronger one, right? And it's gross. Yeah, you're like, oh, ugh, right? Because it weakens the good one you just made, okay? So now think of that right here. This one has 5%. It's some amount, and in this amount, 5% of it's sulfuric acid. This one has some amount, right? And 5% of it, or sorry, 20% of it is sulfuric acid. If I mix the two of those together, what's going to happen? That's going to be somewhere in the middle, right? They're going to mix together. So the new combination of sulfuric acid is going to be between what? Right. It's going to be greater than 5 because the 5 is going to get stronger, but it's going to be less than 20 because the 20 is going to get weaker, right? Okay, so the range of possible combinations, somewhere between 5% and 20%, right? Somewhere between those two. Okay, suppose that the 20 milliliters of 20% sulfuric acid solution is mixed with 10 milliliters of the 5% sulfuric acid solution. What is the concentration of the resulting solution, and explain your reasoning? Okay, before we can do this, we need to know how much actual sulfuric acid we have. So I'm going to give you a second, just do some percent, and find out how much is 20 milliliter, or 20% of the 20 milliliters and 5% of the 10 milliliters. Figure that out first. Alright, so 0.2 of 20 is how much? So that one has 4 milliliters. And 0.5, no, 0.05 of 10 is how much? Okay, so how much sulfuric acid do we have altogether? 4.5. And how do you know that? Yeah, there's 4 milliliters in that one, and there's 0.5 milliliters in that one. How much other stuff, water or whatever, does it say it's water? Oh, we're going to say it's water. How much water do we have altogether? How much? How many milliliters do we have there? We don't have 30 milliliters of water. We have 30 milliliters of solution.
25.
But that one,
30
minus 4.5. 25.5. Why are you doing 30 minus 4.5? Actually, I think we're answering the next question in this question. Because this one's asking the concentration. Yeah, okay. So we're going to go out of sulfuric acid out of the total, which is 30. The next one's when we're going to talk about that. Alright, so what percent is that? If that's, we got 4.5 out of a 30 milliliter solution. Our new mixture is now 15%. That's our new mixture. Alright, great. Good. Alright. What the heck? Alright. Now we want to... Oh, this one's just like the last one. The last question, see. We wanted a 12% solution. So we had 4. We had 4, and we're trying to see how much of the 5% that we need to add. It says write and solve an equation to calculate the amount of 5% sulfuric acid solution Keisha added if the result is a 12%. And so how much of the 20% did she start with? I don't have the question anymore. 20? Alright, so 20 plus some other thing that we don't know. We don't know how much 5% she added to get to the 12%. And again, you can answer this. You can do this question. The process is almost exactly like the last one. Did everybody get about 22.9? No? Okay.
Well, I did it right.
You did it right. Air 5. Yeah. Okay, so 0.12 times 4 plus 0.05x equals 20 plus x. 0.12 times 4 is like 0.48. Is that right? No, 4.8. 2.4 plus.
Okay, 4 plus 0.05.
Oh, I didn't cross multiply right. Hold up. Why don't you stop me? Why did you let me carry on? You're all fired. All of you are fired. You have to find a job. Being a student is not for you. Alright, so this is 2.4 plus 0.12x equals 4 plus 0.05x. And then you gotta move some stuff around. I'm gonna move this. And I'm gonna move this. Alright, over here, is that 0.07? Yes. And that's 1.6? Okay, I can't divide this in my head. It's about